Welcome to today's explainer. Geometry can sometimes feel like a massive puzzle with a ton of moving parts. But what if I told you that you've got the ultimate cheat code sitting right there in your pencil case? That's right. Today we are unlocking the absolute full potential of the protractor. By the time we're done here, drawing and measuring precise angles won't just make sense. It's going to feel like a math superpower. So let's dive right in.
Here's our game plan for today. Number 1, meet your measuring tool. 2, constructing right angles. 3, constructing straight angles. 4, the reflex angle hack. And finally, number 5, practice and final review.
All right, let's kick things off with section 1. Meet your measuring tool, the protractor. Moving right along to section 2, constructing right angles, exactly 90 degrees. What's really fascinating here is the absolute precision of a right angle. I mean, it's not 89 degrees and it's definitely not 91 degrees. It measures exactly 90 degrees. You actually see this shape everywhere in the real world. The corner of your room, the edge of your smartphone, the crosshairs on a grid. It's formed perfectly when one line is totally horizontal and the other is totally vertical. So, the crucial question is, how do we actually draw it perfectly? Let's walk through the steps together. First, you draw a nice straight horizontal line and label the endpoints A and B. Second, take your protractor and place its center mark exactly on point A. Third, you want to align the baseline of the protractor perfectly with your line AB. Fourth, look straight up to the top of the curve, find that 90-degree mark, and put a little dot right there. We'll label that C. And finally, grab your straight edge and join point A to point C. Boom, you've just formed angle CAB, a flawless 90-degree right angle. Section 3. Constructing straight angles, exactly 180 degrees. Now, a straight angle might just look like a boring old flat line to the untrained eye, but mathematically speaking, it's exactly double our right angle. It hits the 180-degree mark right on the dot. In fact, every single straight line you draw actually contains a 180-degree angle perfectly hidden at its center. Building this one is incredibly straightforward. Step 1, draw a horizontal line and put a point A right in the middle. Step 2, place the center of your protractor right on that point A. Step 3, look all the way over to the opposite side of the baseline to find the 180-degree mark and label it C. Step 4, join A to C. Just like that, using the full span of your protractor, you've formed a straight angle. Pretty easy, right? Okay, getting into the fun stuff. Section 4, the reflex angle hack, beyond 180 degrees. All right, it's time to put on your hacker hats because we are about to solve a major geometric problem. What happens when the angle you need is bigger than your protractor? Meet the reflex angle. This is an angle that's greater than 180 degrees but less than 360. If you have a normal acute angle on the inside, the reflex angle is that massive outside angle wrapping all the way around it. But standard protractors only go up to 180 degrees. So how on earth do we measure or draw something larger than that? The secret answer lies in this magic number, 360 degrees. I want you to absolutely burn this vital rule into your memory. One complete full turn, a perfect circle, is exactly 360 degrees. This single fact is the key to our upcoming hack. Just imagine a donut, or maybe a full pizza, representing a complete 360 degrees. If you know the smaller inside slice is an acute angle of 60 degrees, you really don't need a bigger protractor to find the outside angle. You just subtract the inside from the total. So 360 minus 60 gives you a massive 300-degree outside reflex angle. It really is that simple. Let's apply this hack to construct a very specific 315-degree reflex angle. Since our physical tool stops at 180, step 1 is doing a quick calculation. 360 degrees total, minus the 315 degrees we want, leaves us with a smaller inside angle of 45 degrees. Step 2, place your protractor on the vertex. Step 3, mark that smaller 45-degree angle. Step 4, draw the ray through the mark. Because you drew a perfect 45-degree angle on the inside, the angle on the outside is guaranteed to be your perfect 315-degree reflex angle. You just literally outsmarted your own protractor. Almost at the finish line, section 5, practice and final review. Let's ramp up the energy and see just how fast you can do the math. Here is your first lightning challenge. If the inside angle XYZ is 75 degrees, what is the massive reflex angle wrapping around the outside? Think about our hack. I'll give you a second. Yep, you take the full circle, 360 degrees, and subtract the 75. That yields a reflex angle of 285 degrees. Awesome job. Now, let's try it in reverse. To physically construct a reflex angle of 330 degrees, what is the smaller interior angle you actually need to draw with your protractor first? You got it. 360 minus 330 leaves 30. If you draw a small 30-degree slice, you perfectly leave a huge 330-degree slice sitting right there on the outside. Final rapid-fire challenge. The interior given angle is 120 degrees. What's the reflex angle? Run the numbers in your head real quick. Spot on! 360 minus 120 gives you exactly 240 degrees. If you nailed that, you completely understand how to hack reflex angles. Great work today. Let's do a super quick wrap-up of everything we've covered today. A right angle is always exactly 90 degrees. A straight angle doubles that to a perfect 180 degrees. A reflex angle is the big one, living between 180 and 360 degrees. And the ultimate rule to remember is that a complete turn is always 360 degrees, which gives us our magic formula: the reflex angle equals 360 degrees minus the given inside angle. Before we wrap up this explainer, I want to leave you with a quick thought experiment. Look around your room right now. Seriously, look around. Geometry isn't just something that exists on paper. Can you spot a door swung wide open? How about the hands on a wall clock, or the way a laptop screen folds back? Where can you spot everyday objects hiding massive reflex angles? Keep observing, keep practicing with that protractor, and remember that you now have the tools to measure the world around you. Thanks for joining me on this explainer.
Thanks for watching. Bye, students. Don't forget to subscribe for more math fun videos. See you in the next lesson.